So where does light come from? Light sources can be natural or artificial. Our main source of natural light comes from the stars in our galaxy. The closest star to us is the sun. It takes about 8 minutes for sunlight energy to reach us on Earth. A second source of natural light is fire. In nature, fire is started by lightning strikes, volcanoes, and meteors. Some living things can produce their own light, such as fireflies, but often these are animals found deep in the oceans. We call this bioluminescence. Artificial light sources are those made by people to help them to see the world around them. We can pass electrical energy through a wire in a closed circuit to light a bulb. As well as being able to identify light sources, it's important to be able to group and classify them as either natural or artificial. Let's move on now to light reflectors. Most materials can't give out their own light. We can only see them because the light is reflected off them into our eyes. But some reflect light better than others do. We can classify these materials as transparent, translucent, or opaque. We can see through transparent materials like glass and thin sheets of plastic. This is because they allow almost all the light to pass through them. They reflect very little light, so are almost invisible to us. We can also see through translucent materials like frosted or tinted glass, but we can't see through them clearly. And this is because they only allow some of the light to pass through them. The rest of the light is reflected. We often use translucent materials to reduce the amount of light passing through an object. Opaque materials, on the other hand, don't let any light pass through them. This means that we can't see what's on the other side. Some examples of this are wood, metal, and rubber. Most of the light is reflected, although some is absorbed, but we don't focus on light absorption at this stage. What makes a good reflector? Objects that reflect light do so in different ways. Paper, cloth, and rubber are dull objects with tiny bumps on their surface. They might even feel rough when they're touched. Light bounces off the rough surface and is scattered in lots of different directions. Light isn't reflected well in this way. Materials with smooth, shiny surfaces reflect light well. For example, metals and still water. When light hits these objects, the light is reflected quite evenly. Mirrors are made from metal, such as aluminium or silver combined with glass. They have polished, smooth and shiny surfaces that reflect light so evenly that we can see a perfect reflection of objects placed in front of them. A common misconception learners have is that our eyes are a light source. If this was true, we'd be able to see in a completely darkened room. And, well, we'd be superhuman. Another misconception is that the moon is a light source. And while it does shine very brightly at night, this is only because of the sunlight that bounces off it. Let's move on to light and safety. We can make people easy to see at nighttime by adding reflective strips to clothing. We can also use reflective materials to light up a path on a dark motorway. Light from car headlights is reflected off the strips into a driver's eyes. This means that they can see the person or the road more clearly. Sunglasses are made from translucent materials to reduce the amount of light entering our eyes. This is important because bright light can damage our eyesight. And this is also why we should not look directly at the sun or other bright light sources. Our eyes also have a built-in safety feature to control the amount of light that enters them. The iris is the coloured part of the eye. In the middle of the iris is the pupil, a dark opening. In bright light, the pupils get smaller to prevent the eye being damaged by too much light entering. In dim light, the pupils get bigger to allow as much light in as possible. Shadows. Materials that allow light to pass through them or those that reflect light can be useful. But we can also make use of materials that are good at blocking light. When opaque objects block light, a dark shadow is formed behind them. This is because, in the absence of light, there's darkness. Sundials use shadows to tell the time. A simple sundial is made from a plate and a stick. As the Earth rotates, the sun appears to move across the sky. The sun shines on the stick, which blocks the light and casts a shadow. The different lengths and positions of the shadow allow us to work out the time of day. Sunlight can also be blocked by the moon as it moves around the Earth. When this happens, a shadow is cast on a part of the Earth. This is called an eclipse. A total eclipse is when the moon is in a position where it blocks all of the light coming from the sun. The size of a shadow cast by an object changes as the object moves closer to or further away from a light source. When an object is far away from a light source, it only blocks a small part of the light. However, an object close to a light source blocks a greater area of light, so a bigger shadow is cast. Finally, lenses. The field of optics includes opticians and optical engineers. They study the behavior of light and how we can best see things. Our vision can be improved when we use a lens, which is a curved structure that bends light onto a particular point. This produces a clear image. Our eyes have built-in lenses that bend light onto a point at the back of the eye. This helps us to see objects clearly. However, some people have problems with their eyes, so they can't form a clear image of nearby or faraway objects. To correct this, glasses provide extra curved lenses to help focus the light onto the right place, improving eyesight. Artificial lenses can be used to help us see things at different distances, but they can also make objects look bigger. A magnifying glass is basically a handle attached to a piece of curved glass. Microscopes are more complex and use more than one lens to help make tiny objects look bigger. Telescopes use a combination of curved lenses but also mirrors to help us see objects far away in space. This can be quite a tricky area for some learners to grasp. However, it's important foundational knowledge that's needed to understand the concept of scale, which is revisited throughout their science education. Knowing that curved lenses can make objects appear larger helps explain our understanding of the tiniest or more distant parts of our universe, and also how this has changed over time.